Okay, so I think we're just after the hour now, so I think it's a good time to begin today's session. Thank you so much, everyone, and I'd just like to start by saying a very good morning, afternoon, and evening to all of our speakers and attendees, particularly those of you joining us from our members in East Asia, as I know it will be getting sort of well into your evenings now. Want to say a very big welcome to you all for joining us here today for this WTUN for International Women in Engineering Day event. My name is Denise Whitehead and I'm the manager of the World Technology Universities Network. We're very excited about today's programme, having convened 4 expert speakers from across the WTUN's member institutions to speak on topics related to this year's INWED theme, so International Women in Engineering Day theme of Enhanced by Engineering. You'll have seen when you registered from the biographies and areas of specialism of our speakers that they bring with them a diverse range of experience, which further exemplifies the breadth and depth of the field of engineering itself. As a technology-focused network of universities from around the world, the WTUN believes that it's important to take time to highlight and share details of the excellent research, initiatives and programmes that take place at our member institutions. International days of celebration, such as INWED, provides the perfect platform on which to do so, and whilst also championing and celebrating the work of women engineers in what remains, in many, if not all regions, a field where women are not yet equally represented, whether that be at university level, in research, or indeed in industry. Before I hand over to our chair, I would just like to just say a few words about the World Technology Universities Network itself. So the WTUN, as I said, is a global network of technology-focused institutions, and our diverse membership is united by a commitment to the inclusive advancement of sustainable scientific and technology teaching and research, each of our members demonstrating a commitment to truly equitable innovation for the benefit of people and place. Our members deliver teaching, research and innovation with the direct benefit of people and society. They drive technical and social innovation and entrepreneurship, developing graduates who are global citizens and capable of being the leaders of the future. Working closely with local, national and international government, industry and other organisations, promoting interdisciplinary cooperation and demonstrable impact. I'd like to just thank our chair, Dr. Cristina Tuinea-Bobe, Research and Knowledge Transfer Business Development Manager at the University of Bradford, for being here with us today. Cristina herself specialising in engineering and has 2 multidisciplinary PhDs, one in biomedical engineering and one in semiconductors electronics. Her role at the University of Bradford is to facilitate academic interaction with government and industrial funding bodies, resulting in high quality proposals and projects. Cristina will facilitate a discussion with our speakers at the end of our presentations today, and there'll be some time available for the audience to ask questions after each speaker's presentation. We encourage a lively discussion, so hopefully you'll have some questions for us both within the panel, so if you have questions for each other, and also for our audience members. Today's session is being recorded, as Saffron has said, and will be available on the WTUN's website and YouTube channel to watch back for those of you who aren't able to attend in person. Without further ado, I'd like to just briefly introduce Dr. Cristina Tuinea-Bobe, our chair for today. Thank you, Cristina.
Thank you so much, Denise, for having me. So I'm Cristina, and I'm going to help you celebrate the International Women in Engineering Day. Thank you, Denise and Saffron, for organizing this and supporting our celebration. This year's theme is Enhanced by Engineering, and we are celebrating the amazing work women in engineering around the world are doing to support lives and livelihoods every day. I was looking at what people think about females in engineering, and one of our technicians said, engineering, it's a guy's job. And another person in an article in Engineering Ignorance by Francois said, it is probably politically incorrect to say that perhaps females aren't interested in building things. What I would say to the people thinking like that, we are interested in building things. We are interested in making a difference, and we will prove you wrong that we are not interested in that. Our group and Ubuntu and University of Bradford is encouraging and is creating opportunities for gifted women to build a world ready to make a change, succeed and develop. And this during these programs, we are calling on our colleagues males to help us and support us in making these changes and to play a critical role in helping to build a more gender balanced world. On another note, our thoughts are with our colleagues that are entrapped in war zones, some of them performing professional duties to save and secure lives. During this event, we will find out more about 4 of our women in engineering, how they are enhancing everyday lives and help to build a brighter future through their work. Please feel free to drop questions into the chat box during the presentations. And now we will start with the first presentation of the day by Dr. Rardchawadee Silapunt, Associate Professor of the Department of Electronics and Telecommunication Engineering, King's Mongkut University, Teknologi, Thonburi. The topic is moving forward, revolutionizing dairy estrus detection with Camilo. Rardchawadee primary area of research encompasses the design of Internet of Things solutions, wireless communication technologies for IoT, and the design and application of antennas for 5G and 6G technologies. Dedicated to advancing technology solutions, she actively engages in development of smart farming solution for livestock. Additionally, she has embarked on an entrepreneurial journey funding a tech company with focus on enhancing dairy farm productivity through innovative approaches to smart breeding and health management. Thank you so much. The screen is yours.
Yeah, thank you. Thank you. So everyone hears me, right?
Yeah.
Okay, right. Thank you, Cristina, for nice introductions. So my name is Rardchawadee Silapunt, and I'd like to thank WTUN for extending this invitation to my university and also to me, and I feel honored to be part of this event. So my talk today is moving forward the revolutionizing dairy estrus detection with Camilo with these outlines. For outlines, I would talk about milk production overview. I would talk about estrus detection technologies, and then I would talk about my inventions, Camilo, the smart estrus detection solutions, and ends with conclusions. So the demand for dairy products continues to increase due to growing global populations, although the majority of the market is in Americas. Research reports from various sources indicate that Asia has a significantly higher market growth. For example, as the population increases, the global milk production is insufficient. Like in Thailand, we face a similar challenge. We find that the main causes include low rates of artificial insemination and pregnancy in dairy cows, as well as poor health of the cows. Additionally, issues such as like COVID-19 and war have a lot of impact to the cost of dairy cow feed production. So many thousands of farmers are operating at a loss and have ceased the businesses. Now, the importance of estrus lies in its role in milk production. So cows only produce milk after giving birth to a calf, so which can only happen if they are pregnant. Successful pregnancy depends on accurate detection of estrus, which allows for successful insemination. And in the livestock industry, most insemination processes are artificial. Thailand has like total of 22,500 farms, and 70% of them are small-scale operations with less than 50 cows. So our primary focus is to assess and support this specific group of farmers in Thailand. Normally, these farmers observe the estrus sign with their eyes, which can cause too many errors. The average detection accuracy is only 40 to 50%. So missing one estrus detection forces the farmer to sustain a non-viable cow for another reproduction cycle of 21 days, resulting in substantial losses per cycle. So we think that the technologies would improve this process. So there are several technologies in smart livestock, but we select the IoT approach due to my expertise in communication fields. And I truly believe that data holds significant value and can provide valuable insights for various aspects for cow management. So when we look deep into estrus detection technologies, there are several technologies. For example, activity monitoring, when we can observe the signs of estrus from the movement of the cow. We collect this movement data, process, analyze, and determine the estrus status using sensors like pedometers, accelerometer, or even color sensors. Number 2 is temperature sensors like vagina temperature sensors, but this one is invasive method, so I avoid it. One of my research papers reported about the correlation of skin temperatures and estrus, and we conducted the experiment using skin temperature sensors and applied the machine learning to predict the estrus. Number 3 is electronic heat detectors. Example is pressure-mounted devices. Me and my team, we made several attempts to build this pressure-mounted device to detect the humping of one cow onto the other. Turned out that the sensor slipped off after a short time due to slicky hair and gravity and also body force of a cow. So number 4 is biometric data analysis, like measuring heart rate, measuring respiratory rate, which I think this year me and my team starting to do that. And last one is automated visual system, where we use video surveillance and AI for image processing. But this method is costly and prone to errors because it is quite difficult to identify one cow from another, specifically at night. So our team is developing the Comilo solution for detecting estrus in dairy cows with high accuracy. So the solution can also recommend optimal insemination times consistently. It's also tailored to suit the climate in Southeast Asia, which offers better accuracy than imported solutions from different climates. So the expected outcomes are higher pregnancy rates, healthier dairy cows, and significant increase in milk productions. So let's look at our innovation here. Our solution combines the cutting-edge technology and innovation. It includes smart ear tag sensors that intelligently classify the behavior of dairy cows using super smart, fast machine learning models. Additionally, we used algorithms we developed these algorithms to predict the estrus state directly from the sensor. And subsequently, the data is transmitted over this low-power wireless network like Sigfox or LoRa without the need for router or hubs. So finally, the results are displayed and notifications are sent through the Comilo application, line application, and the text messages. And here's our system diagram based on LoRaWAN. So estrus status is sent wired LoRa gateway to the cloud, where the status is processed and analyzed before notifying users on their mobile applications. So, and I want you to see this is a sample of some acceleration data in X, Y, and Z directions from the humping motion on the left-hand side, which are indicated by the spikes here. So how do we, now I'll explain what we did to improve from the first sensor prototype to the MVP version we have today. So these are the first 2 sensor prototypes that we made, Design 1 and Design 2. We designed the case. The first one, we used lateral sliding sensor box, which easily slipped off. And we collect 200 data points per second that consume large amount of current. And battery only lasted for 3 days. Then therefore, we improved the sensor box to be the top sliding down to the tag, the ear tag here. And we collected 4 data points per second in state, and we can reduce a substantial amount of current consumption. And the battery lasts for 11 days. And this is prototype 3 and 4. We made some improvement on the firmware, and we implemented classification model by maintaining the amount of current consumption. And in Design 4, we add in communication module, remove the unnecessary components, and again, we can reduce a large amount of current consumption. And this time, the battery life lasts for 16 days. And here's our MVP version. Now we changed microprocessor to be AI-enabled. We use Sigfox module for our communications. The weight is only 40 grams. We use magnetic charger that is rechargeable, and battery life can last for 30 days at least. So How do we classify the behavior of the cows from ear sensors? This is the most boring and painful process called activity labeling because it has to be done manually. So we we label by looking at the features eating, walking, laying down, ruminating by assigning the class ID 1, 2, 3, 4. And then we add this class ID, okay, alongside the raw data and then input to machine learning model to classify the behavior. So by using the machine learning model, the right machine learning model and our prediction model, we can improve the prediction accuracy to 90% versus 40% by manual observation. So such improvement could earn a farmer substantially for milk sales per cow and average saving per cycle. Again, we have to make sure that there's a wireless signal in the area of testing and utilizing the solution. So we built our own long-range network and tested the coverage. So here is our local research location in Rardchawadee province, northwestern of Thailand. They are dairy product producers, and here is their farm layout. So they divide their farm in two compartments based on different functions. The red dot that you see here is the gateway location. So think of gateway as a router or hub that you put in a house, but this can go very, very long distance. And then we set up the network, we configure the network while we're having these end devices, which is the sensor attached to the ears of the cow, and then send the data to gateway. And then the gateway, beyond the gateway, we have a switch and a router with a SIM card that will be used to transmit the data through cellular network to the cloud and to the internet. And this is pictures of gateway installations. The higher, the better. People said that. But in our case, because it's kind of like the farm is like in rural type areas, so we didn't have to like place it that high. So the height is only 10 meters. And the signal strength in the farm looks pretty good by our indoor coverage test. So here is the data that we see on the network server. You see there's a receiving time, there's a device ID. So this is the data packet that's been sending to the network server. And then our software team wrote the API to retrieve this data, translated them into information that users understand through the mobile application. So not only that, the reasons that we do long distance, we do like this low power wireless network, a long area, because there are a lot of farms in the area. So that we have to also make sure that there's coverage in outside area beyond the farms. So we use the same sensors, attach it onto on the roof of the car, and just drove around the farms and measure the maximum distance before signal loss. And here is outdoor coverage. So you see at some points the maximum distance is small due to a lot of buildings over there. And here is long because most area is a flat terrain. And then in order for users to be able to use our applications, we had to develop this Comilo application, which contains many attractive features. We have in-app line notification, text messages, notifications. The hour asterisk we can notify 3-level asterisks like no detected, warning, and heat detected. And also we recommend artificial insemination time, show the battery level, even offers the expense tracking features. And to make it easy for Thai people, it also comes with Thai menu and English menu. So this is our beta version, and this is our MVP versions, where we can add input cow information. We can add, delete, add a device. We can notify the asterisk and AI recommendations, and the farmers can also do balance checking or bookkeeping using our application. So in the future, we plan to build Comilo platform to connect farmers, maybe for knowledge sharing or a marketplace. So here are testing regions where there are more cow farms, and other regions in the countries is in northeastern and southwest. And without these partners, my project would never come through. So lastly, my conclusions, Comilo is an innovative solution designed to revolutionize estrus detection in dairy farms. So this is a cost-effective solution that can ensure affordability. I want farmers to be able to buy it with high qualities. We can achieve up to 90% of accuracies, so that I believe we can enhance breeding management and maximizing pregnancy rates. So we use smart ear tag sensors that light low power consumption and easy to recharge come with machine learning capability to accurately predict the estrus status. So in the future, we plan to conduct more on-site tests to confirm the accuracy and stability of our solution before we plan to do market launching in a year or two. So acknowledgement goes to these two funders and RCT and TED funds. And thank you for listening. So I'm ready for your questions.
Thank you so much for a very nice presentation. Do we have questions from the floor? Please just unmute yourself if you are in the panel. And from the other attendees, we are waiting for questions in the Q&A. Sorry, Then I'll ask a question. Do you see your product growing and maybe passing over to the end user, like milk customers or something like that? Because all of us, we are very worried about the quality of the products that we are buying. More of us, we are looking into pesticides, hormones use, and all this. Do you see it growing and actually bridging into the market of the end user of these products?
Exactly. That's what my plan.
Yeah, right. From animal safety point of view, do you see it also, because you have an electronic device that is attached and so on, like with the climate change, we are seeing increased temperatures and so on, and animal safety is crucial. Creating pens, for example, that they have shadow and so on, you can look like diverting them somehow, maybe through sound system or something like that.
Understand.
Do you think your platform could support anything like that?
I think so. My comments. Let's start with my sensor. So we try to lower the power consumptions and also the energy that emitted out from our sensors. And so we have to take care of the case. We have to use like biosafety case just to make sure that the cow is safe during using our products. So for my part, I'm responsible for that. But for external environments, and I cannot control. but we try our best to make sure that cow is safe. Here we have really like strict regulations for researchers like us. The government enforces us to pass like some certain tests that make sure that we can take care of animals in research. So we're aware of that.
Same in the UK. Yes.
Yeah. And
we
it's
are
hard
just trying to yes. For us, I totally relate to that. You touched on the robustness of the sensor and the safety of it, and I quite like your miniaturization steps and how you optimize the energy. On the cybersecurity side of it, how do you deal with that? How do you secure that nobody's tampering with the data and nobody has illegitimate?
As of now, when you talk about, you mean data breaching or something like that?
Data breaching.
Yeah, well, we have right now. We only have protection for the application size. We do like two-step or double verification before logging in to use our applications. But for the network and device parts, yes, that we have to do some studies. Yeah, I know that people. I mean, the hacking could happen in the network layer. That is thing that we have to take care of.
Thank you. Any other questions?
We do have a question.
Oh,
yes.
Sorry.
Hello. Yeah, we do have a question in the Q&A. Perhaps I can just pass it on to the speaker. Just to say that there was a triaxial accelerator collar type sensor for a similar application in cows, and the question was just that could you perhaps comment on the pros and cons between the collar one and the ear tag sensor?
Okay, I got this all the time. So like there is conflicts between the two. Like if you use collars, you can have big batteries, right? And it lasts more. For the ear tag, it could, in terms of batteries, it's like it runs, the battery life is shorter, much shorter. But the reason that I use the ear sensor is because when you want to monitor the movement of the cow, so the ear is so sensitive and flexible, when it changes the positions of movement, you can detect it much more clearly than the neck. That's why I chose. But when we go like into the real farmers, like farmers, we visited the farmers, and everyone says the same thing. Professor, please use the neck collar. So, but then I mean, the information I got, and I decided to do ear sensor just because like a very, very big veterinarian that is my consultant, he suggested me too. But now, yeah. So then I put in my roadmap, first year, I will do ear sensor, and the next year I'll start on neck collar. Just to prove that, yeah, they can do similar, they have similar performance.
Thank you so much. And sorry, Dennis, I didn't, it wasn't updating. Something is happening with Microsoft these days. Yes.
No
Thank you so
problems.
much.
Why we're here.
Yes. Thank you so much for very insightful talk. We will move to the second speaker of today, Dr. Rohayanti Hassan. She is Associate Professor and Quality and Safety Manager in the Faculty of Computing, Universiti Teknologi, Malaysia. She has 18 years of experience in software engineering and project management. She has actively contributed to various high-impact projects as a consultant and has a deep understanding of both waterfall and agile methodologies. As an educator, she focuses on teaching software engineering, software quality assurance, and requirements engineering. She has also extensive experience as a consultant and in system development projects using both waterfall and agile methodology, as well as in ICT blueprint development and as a certified agile project management practitioner. The topic for today is waterfall versus agile software project management, the challenges of women software engineers. Thank you so much. The screen is yours.
Thank you, Chairperson. Right. So can I share my slide next?
Yeah. Yeah, we can see it. Thank you.
Okay. Thank you. Right. Good afternoon, everyone. Right. It is an honor to be a speaker at this reputable event today. And I'll present on this waterfall versus agile software project management, the challenges to women software engineers. Okay, yes, my name is Rohayanti Hassan, and I'm associate professor from this Faculty of Computing, okay, Universiti Teknologi Malaysia, UTM, and I have around 18 years experience in software engineering and project management. I have been consultant on various national projects. In education, I focus on teaching software engineering, software quality assurance, and requirement engineering. And also, I have experience in as a consultant in ICT blueprint development. Right. Okay. So, yes, the motivation I joined this event is provide you, okay, comparison, okay, between waterfall and agile methodologies, focusing on challenges to women software engineers. I believe that understanding these methodologies is crucial, okay, for addressing obstacles and opportunities for women in software engineering. So, in line with our theme today, enhanced by engineering. So I hope so that I can promote the best practice, share some insights, again, to improve software engineering practices and create supportive environment for all women engineers. So, okay, now I would like to elaborate on the project management methodologies. Okay, first here we have the conventional methodology called waterfall methodology. So it is a linear and sequential approach, okay, following a strict order of phases. Okay, there are key phases involved. Okay, we have the requirement phase, in which we're gathering and documenting project requirements. Okay, next we have the design phase, okay, where we creating system architecture and design. Okay, next we have implementation phase. Normally we develop and code the project. Okay, next we have the verification phase. Okay, we do the testing and validating the system. And finally, we have this maintenance phase. Okay, normally we perform the ongoing support and updates. Okay, so the advantages of waterfall, okay, it is very clear structure. It is well-defined stages and timelines. And it has a very comprehensive documentation. Very thorough and detailed documentation is required. Okay. Disadvantages, somehow it is inflexible. Okay, difficult to make changes. Okay, once the phase is completed. Okay, it has long feedback cycle, so somehow delays user feedback and issue resolution. Okay, next we have here agile methodology. So it's quite current trend. Okay, in project management. It is iterative, okay, incremental approach, so that we can develop the project through repeated cycles. Okay, the key principles are flexibility, okay, adaptable to changes throughout the project. Okay, it promotes customer feedback, promotes regularly, integrates user feedback, promotes continuous improvement, okay, focuses on ongoing refinement and enhancement. Advantages, yes, it supports high flexibility, easily accommodates changes of new requirements, promotes continuous feedback, okay, promotes regular user involvement, ensure alignment with needs. But the disadvantages, it has a risk of project scope expanding without control, and it really needs require discipline, needs strong management to avoid chaos. So let's look at detailed comparison, okay, in terms of workflow structure. Okay, waterfall, okay, again, it is a linear and sequential process with distinct phases. Okay, then each phase, okay, must be completed before moving to the next. Okay, the structure is very rigid and very minimal overlap between phases. Meanwhile, the agile, interactive, incremental process with overlapping phases. Normally, the work is divided into small iterations or sprints. Okay, then allowing for simultaneous progress on different tasks. Okay, this structure actually promotes flexibility and continuous improvement. In terms of adaptability to change, okay, waterfall has low adaptability. Okay, changes are challenging to implement once a phase is completed. Okay, changes require going back to the initial phases, which can be time-consuming and costly. Okay, this rigidity can lead to issues if initial requirements were misunderstood or incomplete. But for agile, it is high adaptability. Changes can be made at any stage of the project. Okay, agile embraces change actually with each iteration, allowing for reassessments and incorporation of new requirements or adjustments based on feedback. Okay, this flexibility helps to quickly adapt, okay, to evolving project needs and market demands. Okay, let's look at in terms of feedback loops and iterations. Okay, waterfall has long feedback cycles, okay, with feedback typically gathered at the end of each phase. Okay, user or stakeholder feedback is often only incorporated after the entire project or significant phases are completed, leading to potential delays in addressing issues or implementing improvements. However, in Agile, continuous feedback loops and short iteration cycles, the regular feedback is gathered at the end of each sprint, allowing for immediate incorporation of user or stakeholder input. This approach, ensures that the project evolves according to actual needs and preference. More comparison here in terms of team dynamics and collaborations. For waterfall, define roles and responsibilities, often leading to silo work environments. Teams work in a more compartmentalized manner, with each group focusing on their specific phase. Collaboration between teams may be limited, which can slow down problem solving and innovation. In Agile, cross-functional teams with continuous collaboration is provided. Then Agile promotes teamwork and communication across all phases of development. Cross-functional teams include members with varied expertise who collaborate closely, fostering a supportive environment, enhancing problem-solving capabilities. So, yes, I believe that challenges for women software engineers in waterfall is due to the lack of flexibility, and it has a longer feedback cycles, and it leads to potential for isolation in distinct phases. Meanwhile, the challenges for women software engineers in Agile, it has continuous adaptation, require continuous adaptation and high-paced environment. Need for frequent communication and collaboration, and balancing work-life demands is so crucial. So to overcome these barriers in waterfall, we believe that the women engineers need to advocating for inclusive project planning. So somehow encouraging mentorship and support networks, may work. Then promoting to implement the flexible work arrangements, to deal with this waterfall methodology. Then to overcome the barrier in Agile, somehow we can promote, clear communication channels, and we can fostering a supportive team culture, and we can try to emphasize it, work-life balance. So as we conclude here, due to the rapid technological changes, and also Agile methodology is increasingly favored, due to this latest technological advancement and AI integration. So we believe that our women software engineers, we must empower them. So our women software engineers, must upgrade their skills, must ready to upgrade their skills, then keep on continuous learning, keep on engaging in workshop, courses and certifications, to stay updated with Agile methodologies and emerging technologies. And also, women software engineers should actively participate, try to join professional networks and communities, to foster collaboration, share knowledge, and stay connected with industry trends. Then leading innovation by embracing Agile practices and ongoing learning, women software engineers can lead innovation and drive positive change in the software engineering field. Here with me, I have my team as well. that able to deliver this project management course, short course. We have Dr. Adila and Dr. Shamudin as well. We all has been certified with Agile PM practitioner. And I guess a not bad list. Okay, if you have further inquiries, you can contact us. So I guess thank you so much for your attention.
Thank you so much for the very nice presentation. Questions from the floor, please. I will start from my experience because I do a lot of project management, and
Yes,
I am
please.
a agile supporter, but I always face difficulties because agile has very little leadership involvement at the different stages. Is giving you the freedom, to progress the project quicker whenever you think that stage is free. How do you think about the adoption? How do you convince the senior management to adopt an agile process that doesn't require your boss actually okaying the moving of the project to the next stage? Especially coming from a female is quite difficult. In the UK, I face this kind of difficulties. So how do you overcome this? And convince them that is the best to adopt agile instead of waterfall?
I would say I prefer to choose them, the ROI between these two things. I mean, they may have the existing project methodologies. Okay, let's say they already have the waterfall. So let's say I want to introduce this agile. So somehow I must show to them the return on investment when they use this waterfall and use this agile. So from there, they can evaluate the benefits is more towards which one for them. Mm-hmm.
Yeah, so it's okay to let go a bit of control if you have some gain on the quality of delivery and of course economic gain. Yes. If I would be a 18-year-old young woman thinking to do software engineering, what would you say to that 18-year-old? Why should I join the line of software engineers? What is in for me? Yes, at 18.
Okay. Because my student, the youngest joined us is 18 years old as well.
Yeah.
Okay, I would say like this. Because the current job demand in the market is related to something is computing, digitalization. Okay, somehow we cannot run away from this area. I mean, software engineering, software developer. And I think because COVID just give us opportunity to working remotely. So I guess this is opportunity for women to become a software engineer, right? So yeah, everything you can balance your work and your life using your based on your own time, okay? As long as you're able to deliver the project, the task on time.
Thank you. Yeah, I find attractive, for example, working in engineering, especially now that we can work, as you said, remotely, that you can have time with your family whenever it's is required, and the salaries are very good, so very rewarding, and you can put your children in a very good school, and yeah, so it's coming with shortfall of mentors. Especially people that they made it and they made it successfully. And how do you deal with that? Especially in software engineering, are so very few females and very few male capable and willing to mentor females software engineers. Yes. So how do you deal with this?
Okay. In fact, my mentor was a male, right?
Very lucky.
Yeah. It's hard to find. Actually, it's hard to find a female mentor, especially in Malaysia. It's not really our culture, right? But somehow, yes. I guess we have to be open. Okay, open mindset. So regardless your mentor is female or male, so as long as they manage, they really want to share you the knowledge. Okay, I guess why not? You just grab the opportunity, right?
Yeah. Thank you so much. Thank you for your presentation, and thank you for answering so open to all my questions, especially my 18-year-old me that wanted to do software engineering. We will move to the third speaker of today, Dr. Sirirat Rattanachan, Associate Professor, School of Ceramic Engineering, Suranaree University of Technology. Sirirat's research team developed a customized calcium phosphate bone augmentation or personalized calcium phosphate bone graft material that was developed for bone replacement as a bone replacement material by Thai researchers. The research has been granted 2 patents. The topic of the presentation today is revolutionizing bone surgery with customized calcium phosphate bone augmentation. The screen is yours. Thank you.
Yes, thank you. Thank you very much for introducing me, and I want to share my screen. Okay, and this one that you can see the screen. This is
yes, it's perfect. Now it worked. Thank you.
Okay, thank you. Good afternoon in the UK, and maybe in Thailand is near it mostly to say good night. Okay, I'm honored to be here today to share my insight with you. Thank you for give an opportunity to join the WTUN for International Women in Engineering Days webinar event, and share about my work and my experience with all of you. Okay, this topic I want to share with you is about revolutionary bone surgery with customized calcium phosphate bone augmentation. Okay, as about me, my name is Sirirat Rattanachan, and associate professor in School of Ceramic Engineering, and that is similar field of material engineering, but especially in the inorganics. Okay, and now I'm role as Deputy Director of Technology at in the Departments of Administrative and Corporate Communication at Suranaree University of Technology in Thailand. It's the north edge of Thailand, Nakhon Ratchasima. Okay. And it's about my team that I work with multidisciplinary fields, not only in engineering, but also doctor, dentist, veterinary, with the social and other many fields. Especially I work with my graduate student who has the energy and big passion to drive research work with me. Okay, they have experience to do the research in abroad. For example, in the UK, University of Manchester and University of Milan in Italy. And they are now already graduate and go forward. So that's the things I want to share with you that about my research that develop a new products for the bone graft that I want to present in the 5 parts. I would like to give you some background. That first is importance of bone surgery revolution. Okay, and for what is important for the bones surgery revolution? That you know that now we have aging population increasing year by year, and we have the patient many patients with the bones fracture occur 50 million times per year, and there show that osteoporosis, that to make like a bone fracture, easily to fracture, and in 2015, that 1 in 8 people globally was aged over 60 years old, and 29% of people aged over 65 years old are diagnosed with osteoporosis. So we found that the people with bones fracture occur 50 million times per year with nowadays. So if the bones fracture, at especially in the aging people, the healing is very difficult for them, and the bones will fracture the small fracture. So they need to use the bone graft, like artificial bones. Normally we use allograft. Autograft, this means that the bones of the host, of the own host, used for any part of the body, and operate to and cut them to grow other side in the body for the older host. And another that we use allograft is for another people, and xylograft is for animal bone animal, for example pigs, cow. So this is normally the bone graft that doctor use, but now we can synthesize the new material from the many material, for example ceramics and polymer, and put in with bones phosphogenetic protein or DBM for induce the bone growth. That the application for the bone graft that can use the many parts of the body. For example, spinal, xylofascians, dental bone graft, or joint reconstruction, or tumors, fracture, and the bones defects, many bone defects. So that we know that traditional surgery method for bone repair often face limitation, especially when it comes to the small defects area or complex shape. Fracture, void, or other bone defects require solution that is not only effective but also adaptable to specific needs of each patient. So we develop the enhanced surgery precision in advanced we can make like advanced 3D imaging technology and customize the surgery template. That the patient-specific templates improve accuracy, minimizing surgery time and reducing the risk of complication, and optimize the surgery outcomes for the patient. So for this innovation that we want to make the personalized patient care, like improve patient comfort and enhance long-term results, and the thorough treatment plan that we can save the cost and save time and save pain to the patient. The second is a customization in calcium phosphate bond augmentation. That this innovation that tailoring solution to individual needs, for example, customize around for tailoring solution to the specific needs for each patient, and precision in application. And I want to give you a background about the bone graft. That normally that doctor use like a granule, is some kind like a big powder like this and many porous. So when doctor use that, they put in the bone defects, but this kind of the bone granules can be dispersed into the defects. We cannot control the shape, and if dentists want to use that, they need the membrane to cover this the bone graft to limit their area. But in this innovation that I use that like kind of the cement, mixing this powder with the liquid to make like a place and easy to handle and operate. So we can make many shape moldables and no need for the membrane. And we can print through the 3D printing. And this innovation that can injectables. So it can institute hardening. That means that our bone cement can be processed, injected into the small defects area, and then hardened within the body, providing structural support and promoting natural bone regeneration. So we develop calcium phosphate cement that, but we have cell setting property, injectable, bioactive, biocompatible, and biodegradable. But the disadvantage is the poor mechanical property. So we add some kind of polymer. In this case, I study about the polyacrylic acid with bioactive glass to make like a biocompatibility with the bone tissue. So this combination with a polymer, this material that can increase.
I think we lost the connection. We'll give it a couple of seconds to return.
Now, I was just going to suggest there was a question for our previous speaker in the chat. I don't know if our presenter is still here. Maybe she can answer the question whilst we see if Sirirat can make it back in. It was specifically about
not updating. I can't see it.
Oh, that's okay. That's why
it's
Saffron
something
and I
wrong with Microsoft. Sorry.
Yeah, global issues with Microsoft, I think, at the moment. But it was a question for Rohayanti, just around the gender balance for software engineers. Whereas, you know, in other areas of engineering, it's very explicit that there's civil engineering is perceived to be very dominated by male engineers. So I suppose if there's any data on the gender balance in software engineering, I guess both perception and reality. But I don't know if Rohayanti is here and available to take that question whilst we see if Sirirat can reconnect.
Okay, I would like to answer the question. Is it possible?
Yes, please.
Okay, we probably asked this question, right, about this gender balance, okay, in software engineers. Okay, I'm talking about in Malaysia. Okay, somehow quite balanced. We have these female software engineers because, okay, in software development, there are many phases, right? Okay, start from the requirement gathering until we deploy the software. Okay, so we can see that the software developer, software designer may be dominated by the male. But somehow for the documentation part, requirements gathering, so it is more tendency to a female software engineer. Okay, this kind of works in Malaysia is dominated by this female software engineer. And where we, in the phase of testing, okay, somehow, yes, we have this balance of female and male software engineer. This is the current trend in Malaysia. So somehow, so I would say in Malaysia it's quite a balanced gender as the software engineer.
Thank you so much for your answer.
If our next speaker is ready and available, we may just need to move on, and then hopefully we'll get her back, perhaps to finish off. It happens. Yeah. This is what we have to do, isn't it?
Yes. Thank you so much, Denise, for trying to reach Sirirat and check if she's still online. We'll move to Dr. Karin Nachbagauer, Professor of Applied Mathematics at University of Applied Science, Upper Austria. Karin received her degree and PhD from Johannes Kepler University Linz and has taught in numerous institutions, including management centers in Innsbruck, Austria, and Technische University Munich before working at University of Applied Science, Upper Austria. Prior to her professorship in applied mathematics, Karin worked as the head of project Rattanachan, the embedding of the adjoining method in multi-body dynamics. Karin, the screen is yours. Thank you.
So thank you, Cristina, for your nice introduction, and also thank you to Denise for organizing our session today. So today I want to present an initiative for encouraging more female students to pursue STEM studies or career in engineering or science. So my talk is not in the typical technical science session now, but goes more into the direction of the second speaker of today from Rohayanti from Malaysia, because she talked about challenges and challenging in encouraging, mentoring, networking women to go to software engineering. So our initiative goes more in this direction. So I'm very happy to present you our initiative today in this nice setting. So before I want to start my presentation, I just want to introduce myself and my home institution at which our initiative takes place. So my name is Karin Nachbagauer. I have a professorship for applied mathematics. On the one hand, at the University of Applied Sciences in Upper Austria. I want to show a small map from Austria to show you where I come from. So actually, this is the map of Austria. It lies between Germany and Italy in Europe. I marked here some major cities, so to say, in Austria, that you can get an imagination where I stay and where my home institution is. So here you see Munich, you see maybe Innsbruck, here would be Vienna, here you see Salzburg. So we are in the heart of Europe. And actually I have two home institutions so far. So I'm working at the University of Applied Sciences, Upper Austria. I have a professorship for applied mathematics. And I work here at the campus in Wels. It's the engineering campus. And as you introduced myself before, I work as the main software developer of the multi-body dynamic software FreeDyn. So if you imagine a multi-body, so to say, it's a system connected. So it's a system of multiple bodies, could be rigid, could be flexible, and they are connected by joints. As you can see, for instance, here a simulation from my research work of a wind turbine, or you can see here a whole vehicle could be simulated as a multi-body system. So this is what I do in my research at the University of Applied Sciences in Upper Austria. But I have a second home institution, the Technical University in Munich. I work here at the Institute for Advanced Studies, and I do here digital twinning for robotic systems. And in my research focus, I do soft robotic systems. Like here you see a walking robot, but the walking robot should have a flexible arm in future. Like you can imagine like an elephant's trunk. Or here you can think of soft grippers for flexible robotic systems in the future. So this is my topic here. I have here a small research group as well in Munich. They are doing research on soft robotics. So just that you have to give you a clue on what I'm working in research. So actually, now I want to present you our initiative. Sorry. Hit the wrong button. So I want to introduce now our initiative. So I called this Intercultural Female Collaboration and Enhanced by Engineering, because you also chose this topic, and it fits perfectly our initiative. So we are organizing each year an international summer academy in engineering for women. The initiative is aimed at encouraging more female students to pursue STEM studies. And we not only want to engage them to study STEM, but we also want to advertise careers in engineering and science. So we don't only look at the problem that less girls are entering STEM studies, but what also the problem is that they get lost during their bachelor or their master degrees and not finish their studies, or maybe not enter then a career in engineering and science. And this is our initiative here. We want to get the girls into technical engineering, but also we want to keep them there. So our target group consists of already engineering students. So our target group is not the young girls which do not know what to study yet, but they are already students in engineering. They are aged in the early 20s, and they are coming from all over the world. And we are targeting girls who want to expand their technical and also scientific knowledge. They should explore the impact of technology on our society of the future. And we also try to get students coming from very male-dominated disciplines and programs. They are often struggling in non-inclusive environments. And of course, they also want to have their own network, so to say. So I'm also now referring to Rohayanti's talk in the second presentation, because the benefit here of our course goes directly into the conclusion of her talk today. So we want to foster a supportive team culture. We want to foster and encourage mentoring. We want to encourage networks. So what we are doing is we are giving workshops, courses, lectures. We are have company visits and also project works. We want to reflect diversity in engineering, and we also want to motivate them to continue their studies if they are wondering about maybe changing subjects or things like that. So we want to show them also the opportunity to connect to other like-minded female STEM students and to start their women in engineering networks, as men usually naturally do. So we want to really force them to also found networks, mentoring, and a team culture in technical engineering society. Actually, so sorry, doesn't work as I like. Yeah. What is the program about of our International Summer Academy? So actually we have a very big project work to do. So they should think about their life in 15 years. So I know it's not a very huge amount of time, but actually they are in their young 20s. And we don't want to say them, so think about the life in 50 years. It's a too long horizon. We want to think that they have finished their studies, maybe started a family, maybe started a career, things like that. So we ask them to think about their life in 15 years. I come to this somehow later. And I come also to the Science Cafe later, because this is a very important point in our Summer Academy. I will give you details there. Second big issue here, lectures. So it's the classical setting of lectures. So we're giving them a scientific worldview lecture, dynamics of space vehicles, water turbine simulation. So you see already it's a very diverse field of topics. So it's really engineering motivated. We have girls from informatics, software engineering, physics, mathematics, electrical engineering, mechanical engineering, civil engineering, but we want to show them with their education, they have a very broad field of career possibilities, and they should stay in engineering because they have a very broad life for career settlements. And we also do some company visits. We visit a water turbine company. We visit the Cornspitz company, which makes a very special kind of bread. It's a worldwide acting company as well. We are visiting the Museum of the Future, where we do an artificial intelligence workshop with them. And we also visit Rosenbauer, which is a fire brigade outfitter, which is also acting worldwide. And in the workshops, we do a lot of very, so to say, new technology topics, also encountering the conclusions from the second talk today. So we want them to stay active with new technologies. So we teach them in ethical and sustainable design. We teach them in predictive maintenance lab, artificial intelligence lab. We are doing current projects in medical technology. We show them a hand prosthesis lab and also food intolerances lab. So very diverse field here also in the workshops. So on the next slide, I just want to give you more details on this project work and on the Science Café. So here you see the project introduction. So we asked them for doing a project. So they should think about their life in 15 years. They should think about daily routines. They should think about family, work, educational life, and also new technologies. So on some new technologies, we can already think about what will be in our daily lives in 15 years. Some could be not charged or settled already, but some technologies are already in a manner that we can think about, okay, we will use this in 5, 10, or 15 years, but they should also think about problems, dangers, things like that. And a very big point should be, on the one hand, in the daily routines, food supply. So they think about the sustainable development goals, of course, in terms of food. So what will be our daily breakfast in 15 years? Will it be in capsules? Will it be a classical breakfast? What about the change in world food and climate action on life below water, life on land, and how do we feed the world in 15 years? But also think about, so to say, health issues in 15 years. Can we think about new pandemics? Could we think about war issues which comes in the next 15 years? So they should really think about the life in 15 years under the umbrella of all these workshops that we are doing with them within 3 weeks. So they have time, so they have 3 weeks of time for this project, and they should take the information from all the workshops with new technologies and things like that. And a very big point here as well is our Science Café. So we call this Science Café. Actually, we show them role models. We want to foster here networks. We want to encourage them with mentoring, and we also want to show them funding in science, jobs in academia, and how to find, for instance, open PhD positions. So what I think is very dangerous here, that we get the young girls to engineering studies. We teach them very good. They have a very good education. They are very intelligent for all these jobs. But how can we lose them then? So in Austria and also in Germany, we have the problems that we lose them and they are not going into the classical engineering careers then. And in this Science Cafe, I show them, for instance, the job market for science jobs. I show them how to find PhD postdoc positions worldwide. So we have, I gathered here the most important job homepages for PhD, postdoc positions, for jobs in research at university, but also in companies. And I also showed them how to get academic positions for research institutions worldwide. So this is kind of how to get the jobs in science and research after their master degrees then. So I guess this is a very important point. Keep them in STEM and keep them in the engineering careers. Yeah. So, actually, I'm almost at the finish line here with my presentation. I just want to show you some insights in our workshops and company visits. So just to give you an insight on how they work in these 3 weeks of summer academy. So they are really in the labs. They are building small robotic systems. We are going to them, to the technical companies. They are trying things in the lab. So we have here a food lab, food intolerances lab. We have here so we did here an escape room game, an exit the room game with technical engineering stuff. So we tried to do some gamification with technical innovative workshop styles. So we really try to make also fun in these 3 weeks. So engineering should not only be lectures and workshops and doing things, but they should also have fun and like to have these workshops in engineering. And actually, I just want to show you statistics. So the Summer Academy was first held in 2014. And since then, it has connected more than 200 female STEM students from over 45 countries across different STEM majors from 80 different academic institutions. So actually, we are also trying to have this international women network by having a network of these academic institutions in engineering. And actually, they form a network in the individual year groups, but also beyond the year groups. So they really have a very good network. In many cases, the students stay in touch years after their graduation in this course, and they also bring their network into their professional lives. So actually, we always get mails from them if they try to get jobs in the individual network there. And actually also we are doing an evaluation with respect to state-of-the-art discussions in open literature. So we're trying to do focus group interviews, we do data analysis, and we also try to do girls' conceptions of technology and being technical and try to omit the danger of girlification. We are really trying to evaluate this each year to get the best of it. And with this, I just want to conclude here. So what is our goal in this initiative? So we want to show them different disciplines, interdisciplinarity and study programs so that they do study in STEM. We want to show them role models, job opportunities, possible careers so that they will stay in STEM. And we also show them life perspective, networks, collaboration, and try to give them the support to also make friendships in this summer academy so that they have fun in STEM jobs. And actually, therefore, we call this summer academy an intercultural female collaboration. And actually, I have to admit, our initiative is only a very small piece of the puzzle. But nevertheless, it's a very important contribution to the future of women's engineering society, giving them a network, giving them also a mentorship and also a team culture where they really want to work in and not feeling forced to work in engineering, but really have fun to be in this life. So and with this, I want to thank you for your attention. I tried to show you our initiative at our university to bring more girls into engineering. If you have any questions, feel free to ask, and I'm also welcome any questions afterwards per mail. If you have any ideas on international collaborations, so we have here, I've put here the contact to our international office. So if you have any ideas on collaboration, international workshops or things like that, so please contact me or Camilla from our international office. So thank you very much for the time slot to present the Summer Academy here. Thank you.
Thank you so much, Karin, for sharing with us your successful program, the successful summer school. We have a question from Rohayanti. Is this summer program exclusive to students from your university, or is open to students from other universities to join?
Actually, it's open for all universities all over the world. So if they have an actual study program, so they are in a bachelor or they are in a master, they can submit to come to our Summer Academy. So from all over the world, every study program, of course, it should be somehow connected to engineering. So we are focusing in our target group for engineering students, but there we are very broad, from civil engineering to electrical engineering, biologic studies, physics, chemistry. So everything is open. All studies from STEM actually can be found in our Summer Academy.
Thank you. A question. Oh, Denise, please.
It was just to jump in, because obviously I work very closely with Camilla, and I'm familiar with this this summer program already via the WTUN. So we have in the past promoted this summer academy to WTUN members, just to raise awareness of it, and we will more than happily do so in the future as well. So as you're all connected to member institutions of the WTUN, keep an eye out, perhaps via your operational board members. But we do, and it's just a reminder really for any activities like this that are happening at our member institutions. If you are open to international students and you want to promote it, then please, Saffron and I are always ready and waiting to receive and promote those on your behalf. So I think this is a perfect, is a good topic to end on, I think, giving obviously sharing the information that we have today, but also then having something that's tangible that we can pass on to the students and the next generation of engineers. But yes, I just wanted to add that, Cristina, just as a reminder that happy to promote and share this among our members.
So very thank you, Denise, also for your initiative also to make marketing here and try to get a very broad field of girls who are interested. So thank you for doing this, and please also I welcome all of you to give this information to the girls in your courses, to the girls in your lectures. If you just tell them there are cool summer academies all over the world where you can do networking and you can learn a lot of things. They are really interested in submitting their abstracts in our Summer Academy, because they also think, okay, we are their mentors, we are their role models, and they think, okay, we can do it in the same way. And if they get the pros and cons of such summer academies from us, from their teachers in math and in physics, they are willing to take part in such summer academies as well. So thank you, Denise, for this.
Thank you. Karin, a question, because your observation, it was that you are managing to get students into the STEM subjects, but the retention of the area when they are going into their work life is poor. Did you observe the girls in STEM, the women in STEM, going towards more managerial roles or diverting completely towards other domains, like maybe accountancy or I don't know, patent law or something
maybe.
administrative? So you've seen them moving into other areas not connected to engineering.
Yeah. So actually, I don't know if this is an international word, but we often call this in Austria, Germany, somehow a bottom of class. So they drop out in their engineering career steps. So of course, engineering studies is not done in a few months. It lasts 5, maybe 2, 6 or 7 years. So it's a very long time range. And we see that they fall out from master degrees, or they not finish with their master thesis. Or they going to jobs not qualitatively in engineering. Like you said, they go then to administrative places, or they go also maybe government places. Everything is perfect, but actually we are wondering, why are the girls not intended to do then the real jobs in engineering? So, and therefore we want to show them the diverse field, so that they see, okay, maybe I studied physics, but maybe I don't see this future perspective here. And we want to show them, hey girls, there are a lot of future perspective for you also in mechanical engineering. So if you're good in physics, you can do everything. If you're good in math, or if you're good in software engineering, as the presentations here, perfect. You can do topics in Internet of Things. You can do topics in all disciplines, so to say. So we just want to broaden their sight on technical applications and possible careers, that they not drop out in because of they don't see the future of their education.
We in the UK, we have the other way around the problem. We have a very depressed intake in the STEM subjects for females. So actually, Bradford, for example, is running a program for 4 to 11 years old now. So we are trying to bring into their mind that engineering is fine to follow, and not just for the girls, it's as well for boys as well, because at the moment engineering is seen as the dirty hands kind of job, and they are not seeing beyond that, and very few of them, for example, even in satellite engineering, we were discussing with these 7 years olds, and they were like, no, satellite engineering is just about sitting in front of your computer like they see in the movies, and somebody talking in a microphone and so on, take off, counting down. So it's perception. But once we have them in, most of our females actually, they go and do job in engineering because they enjoy. Some of them, they go on a placement year, so they go into a company and they work there, and most of them they follow with a job in the same place. But yeah, some of ours, they will go on a project management kind of role, but still engineering connected. But it's very interesting, your observation. Thank you so much for your presentation, and I hope you'll have as many females engineers from the partner universities. For sure, I will advertise it in our engineering and digital technologies faculty, and we'll send you some of our good students. Denise,
thank you very much. Thank you.
Thank you so much, Karin. Yes, Cristina, I just wanted to just finish just with my WTUN hat on again once more, that obviously, you know, it's a great platform to be able to demonstrate and sort of give you an insight into just one of the projects that's happening at one of our member institutions, but also a reminder that you're all members of the WTUN. So this is a route for your own collaborations. So whether that be the people that we have here watching, or maybe academics or research colleagues in your own institutions, if some of the presentations that have happened here today, whether that be at the research level or indeed the programme that Karin has presented on, piques your interest, or perhaps you think there might be opportunities in your own institution either to expand or develop similar program, or you maybe want to follow up and maybe see how you might go about getting that off the ground, then I would maybe, if I may, Karin, just suggest that the WTUN obviously is really keen to support member collaborations. So although it's closed for this year and we funded our exchanges, we do have small pots of funding to sort of kickstart intra-network collaborations between our institutions. We refer to it as our exchange program. So when that opens at the end of this calendar year, ready for next year, perhaps, it would be an opportunity just to maybe kick off a collaboration project for an academic or a colleague to visit from one of our member institutions, maybe find out a little bit more about what you're doing there at University of Applied Sciences up at Austria, to take back and maybe introduce something similar. So that's just one example, but I just wanted to just add that as well, because of course that's what unifies us all here, is that we're members of this network. Yeah, I'll hand back to you, Cristina. We do have Sirirat back on the call, which is great. So I'll hand back over. But yes, thank you very much, all of you, for your contribution so far.
Thank you, Denise. Sirirat, would you like to pick up from where the connection dropped? And yeah,
I don't
please.
know. I don't know. I cannot see anybody on the screen.
If you put the slides, we will try and guide you where we last heard from you, and we will give you the possibility to tell us about your research.
So I present again.
Do it. Yes.
Right?
Yes. Yeah. You are telling us about your team and that they've been in Milan. Yes.
Okay.
And yes, that's where we were. Thank you. So please do start from there. Yes.
This is my graduate student that they have experience in UK, in University of Manchester, and another in the University of Milan in Italy. So now they already graduate and go for work. So I want to present about the 5 parts. I would like to give you some background about the bone surgery revolution. What is the bone surgery revolution? Important that you know that the aging society that increasing year by year, and many people has can happen that osteoporosis and the bone fracture, the increasing occur 50 million times per year, and 29% of people aged over 65 years old are diagnosed with osteoporosis. So when the bone fracture for the aging people, that the bones is very hard to recover, that they need the bone graft or artificial bone. Normally, they use doctor use allograft or xenograft. Is a kind of the natural bones from the another person or from the animal, for example, pig or cow bone. But now we can synthesize the bone graft from the many kind of material. For example, ceramics, composite, polymer, and add some the bones morphogenic protein or DBM, the growth factor with this material. So this application of the bone graft of so many applications. For example, for spinal fusion, osteocellular dental bone graft, or joint reconstruction, or trauma extremely on many area in the bones in the body. So for this innovation that want to enhance surgery precision for the improve the complex shape of the bone fracture. Traditional surgery method for bone repair often face limitation, especially when it comes to small defects area or complex shapes. Fracture walls or other bones defects require solutions that are not only effective but also adaptable to the specific needs of each patient. So our solution want to make the advanced 3D imaging technology and customize surgical template and optimize surgical outcomes. So in this innovation that we want to make the personalized patient care. So we can make like a tailored treatment plan and improve the patient comfort for enhanced long-term results. So in this bone cement as it can cure the bone fracture faster and better, can save costs, save time, and save pains in order to save more life. And this material.
Sorry, Sirirat, your presentation doesn't, the slides don't move. If you clicked on the next one, no, it doesn't move. Sorry. We were wondering if it's just our screens, but yeah, we were.
Okay.
Thank you. Sorry about that. Thank you.
Okay. So this our products this difference from the product that the doctor used. Now doctor use like a bone granule, like a big powder with porosity, and when the doctor want to use this bone graft, they have to mix with the brush and put in a defect area. But in this type of the granule that can separate into the many areas, so they cannot control the shape of the granule. But in this innovation that I make like a cement to mix with powder and liquid to mix together and make like a paste. So this place that can control the injectability and can make many shapes can moldable. And then if doctor use that, it can inject into the body and is hardening into the body. So this type of products that can make like a complex shape because that it can inject through the needle, so they can it can fabricate in the complex shape by the 3D printing. This material is a calcium phosphate, is similar to the natural bones. So the advantage is a self-setting property, injectable, bioactive, biocompatible, and biodegradable. But the disadvantage is poor mechanical properties. So in this research, we need to enhance the mechanical properties by incorporate with polymer. For example, we cooperate with polyacrylic acid. That is a polybiocompatibility. So when combined with the polymer, the mechanical property is increasing, that's similar to the natural bone. The mechanical, the setting mechanics is shown like this picture. That the setting is occur during the precipitation, the solubility and precipitation of the new chemical as natural bones that we call hydroxyapatite. And then we add with polyacrylic acid that can make that happen, that reaction between the alpha TCP and polyacrylic acid and the cross-link with together, so it can make hardening and improve the mechanical property of the material. So for the setting, we need to determine the setting time because that we need to inject through the needle. So the setting time it can be controlled. So we develop many formula to determine the setting time and injectability. That we need to inject that nearly 100% through the needle, and then after hardening, that vitamin evaluate the mechanical property also. And after that, we have to evaluate the cell compatibility with material. So this picture shows the cell morphology. happy staining that we can see the green cells. It means the healthy cell and right cell. That this cell is human osteoblasts and the mesenchymal stem cell that is shown the healthy from within the 7 days. And for the cell proliferation and cell differentiation also are determined by the Alambu. That we can see that the this calcium phosphate cement with bioactive glass that show the higher cell proliferation and the cell differentiation, and is indicate that this material that can use with osteoblast cells, is mean the bone cell, and it can induce cells, induce the natural bones in the human body. So next is advantage of the customized bones augmentation, because this can inject and moldable, so this material can improve the surgery outcome and precious bone reconstruction and enhance implant stability and optimize healing process. So this picture showed the experiment in a rabbit that the doctor deal the hole on the leg of the rabbit and compare with control. The control one, this control is without the without bone cement, and another hole is filled with bone cement, and these operate within the 2 until 2 to 12 weeks. And this show the cross section, and it show that the bone cement can adhere and close in the holes, but some pass into the center of the bone. And after that, the sample was cut and sliced and strained to determine the new bones area. This picture shows the new bones area increasing during the time, and our products show the increasing the new bones area as compared with control one and commercial products within the 2 weeks. The doctor needs fast recovery, and these products show that within the 2 weeks, the bones grows faster than the commercial one and the control one. And this paper that published already in the biomedical materials. So for the chart to the patient anatomy, sorry, that maybe I want to move faster. So the application of different types of the bone surgery that we can make like 3D printing, and because that we can scan the bone defects. It's very complex shape, and to make like 3D model files and scan that, sent to the 3D printing to make like a complex shape, and use this for the customized patient, customized bone augmentation. And another application that I have already published with a surgery doctor that use the cadaveric sample that injects this cement into the nail. And after that, the sample was evaluated the mechanics by the biomechanic testing. Is simulates with walking of the human walking for the everyday life to determine the mechanical property. And this show that with inject with length sample with reinforced with the bone cement that has the lower strain energy. This indicate that these injectable bone cement into the needle into the sample that can make higher and better mechanical properties of this fracture. And this published in this year. So for the future of potential and research in calcium phosphate augmentation, that now we have approved this product approved from the Thai FDA, and next experiment we want to extend to the clinical trial. So that we need the next results in the human. So we have to ask for the ethic and to do this experiment in the next time. Okay. Too many files. Thank you very much.
Thank you so much, Sirirat, for coming back to us and giving us the presentation on your amazing work that you are doing about bone augmentation. Questions from the room? I work in the biomed area, so and a bit on implants, but I was using other materials. I was using PEEK for polyethyl ketone. From mechanical point of view, glasses like the one that you are using are quite brittle. How much is changing from a pure kind of phosphate, calcium phosphate, when you are adding the polymer, the brittleness, because that's the problem usually there?
I think that we have to prove the many experiments that is ethic the regulation for the FDA, because that polymer that with the ceramic is makes like a complex reaction when it's stood in the body. That some polymer has a unreact with the material, so we have like a monomer and degrade into the body. So many challenge to test and evaluate in the next future, and challenge for the approval for the FDA also.
So did you do any rats or rabbits testing, like on live animals?
Yes.
Yeah. Okay.
Yes.
Yeah. And those ones were successful with absorption and osteointegration. Yeah.
Yeah.
You showed the 3D printing of the of your material. How do you deal with the nozzle blockage? Because that's the biggest problem. It's starting to cure as you are 3D printing. And so how many centimeters square did you manage to 3D print there?
Now I use maybe 3 diameter of the 3 centimeters.
Right. Okay. So quite good.
Yes, and we can make a whole porosity that we can control the size of porous.
Yeah.
Yeah.
And on the degradation rate, did you see it with the polymer degrading at a decent rate to have full osteointegration there?
Yeah. Now in the animal, that's very difficult to know that which is degrade material, because that materials we need like put some radioactive agent, because that we need to X-ray that is very difficult to the difference between the calcium phosphate and polymer now, because that they mix together.
Yeah.
So
we did dental things. Yeah. And we mix in the polymer ceramics. Yeah.
Yes. So but in the individuals experiment in the cell or in the in vitro that show that calcium phosphate can degrade faster than polymer.
Than the
so
polymer.
I think that, but in the situation in the real live animal, that I'm sure, because it's very difficult to determine now.
Yeah. Thank you so much for coming back and for telling us everything about your research. Denise, do you want to open the discussion to everybody and for the last 5 minutes of the meeting?
I was just going to suggest maybe, of course, if there are any questions from our panelists to any of our panelists, or if there are any questions that anyone wants to ask, you have just a minute or so to do so. But if there's not, I think that, there's been plenty of discussion throughout, which I'd thank everybody for their contributions and for their insightful questions. I know Cristina has already expressed thanks, but Sirirat, I'd just like to say thank you again, just for persevering with the tech and coming back and completing your presentation. It was really interesting to hear more about your research in this really interesting and relevant and life-changing field for, as you said, so many, and with an aging population globally, and the like you said, the statistics around the diagnoses of osteoporosis globally, it's only going to become more relevant to us as we all age, and indeed as our population get older. I do appreciate everyone's time. So if there is any questions, perhaps there is just maybe time for one, maybe two. But if not, as I said, this session was recorded, which is fantastic. Thank you for sharing that with you. And if you've enjoyed this session, please do keep an eye out for future WTUN events. As I said at the beginning of the call, international or days of or UNESCO celebrations, these type of things are always a really good opportunity or an excuse to convene, but we're always looking for ideas, and also I'm more than happy to convene and promote work that's happening at our member institutions, of which there is much and lots to be explored. So hopefully that's piqued some of your interest. It may also, we've had opportunities come out of events like this where researchers have actually identified some commonalities and gone away and actually worked on projects together, which is always great to see. But if there isn't, hopefully you can't hear that too loudly. There's just a very loud motorbike going past my window. It seems to be timing just perfectly for when I'm talking. But if there isn't any questions, I'd just like to just give a final thank you to our chair, Cristina, for stepping in, for facilitating and hosting today's session, and for Saffron as well for doing all of the organisation behind the scenes that we don't get to see, but is the reason that we're all here and able to make it. So yeah, once again, on behalf of the WTUN and for the International Women in Engineering Day 2024. Thank you very much to all of our speakers, and I wish you all a good evening. And for those of you who are in East Asia, you can go relax into your, what might be now quite a late into your evening. So thank you.
Thank you so much, everybody.
Thank you.
Afternoon and
Thank
evening.
you.
Bye. Bye.
Thank you very much for organizing.
Thank
Thank you. Bye.
Bye.
Bye.